Welcome back to Science Bits. Today we're diving into one of humanity's most audacious dreams, colonizing Mars. Why Mars? What obstacles stand in our way? And how does Elon Musk plan to turn science fiction into reality? Let's explore. Mars is often called Earth's little brother. It has a 24.6-hour day, seasons and polar ice caps. But make no mistake, it's a hostile world. Its thin atmosphere is about 95% carbon dioxide with barely any breathable oxygen, and temperatures can plunge below 100 degrees marks. Yet, its relative closeness and the presence of water ice make it the most realistic target for a human colony. First, there's the problem of getting there and landing safely. Mars' thin atmosphere doesn't provide enough drag to slow a heavy spacecraft, so engineers need heat shields and retro rockets to brake a lander from interplanetary speeds. Second, radiation. Without a global magnetic field or thick atmosphere, Mars is bombarded by cosmic rays and solar particles. Studies estimates that astronauts could receive about 0.66 sieverts of radiation during a round trip. That's far above current career limits, so habitats will need meters of rock or water shielding and advanced medical countermeasures. Third, life support. Mars' atmosphere and soil lack the oxygen and nutrients needed for humans and crops. Scientists are investigating hydroponic and aeroponic systems, fertilizer production from Martian resources, and ways to extract water from subsurface ice. Elon Musk's company SpaceX has become synonymous with Mars. Its centerpiece is Starship, a fully reusable two-stage rocket designed to carry over 100 tons of cargo to Mars. It runs on liquid methane and oxygen propellants that can theoretically be produced on Mars by combining atmospheric CO2 with water ice. This process, known as the Sabatier reaction, is the cornerstone of in-situ resource utilization, allowing the production of fuel, oxygen, and even fertilizer on the red planet. SpaceX's roadmap calls for multiple uncrewed Starship missions to deliver habitats, power systems, and autonomous robots that will set up basic infrastructure. Musk has suggested the first human Starship could depart as soon as 2028-2030, depending on the success of earlier test flights. Beyond current plans, researchers are exploring imaginative solutions to Mars's problems. Building habitats underground or covering them with regolith could reduce radiation exposure. NASA and SA are also investigating pharmacological treatments and active shielding. To cut the 9-month trip, scientists are studying nuclear, thermal, and electric rockets that could get humans to Mars in a few weeks. Faster journeys would reduce radiation exposure and psychological stress. Some futurists suggest releasing greenhouse gases or deploying orbital mirrors to warm Mars and thicken its atmosphere. While intriguing, these concepts remain centuries away and would require unprecedented energy and resources. So when might we see a human footprint on Mars? SpaceX is targeting uncrewed missions in the 2026-2028 launch windows and a possible crewed flight around 2030. Creating a self-sustaining settlement, however, will take decades. Even Musk concedes it could take 20 to 30 years after the first landing to build a city that doesn't rely on Earth for supplies. Many scientists warn that these timelines are optimistic and that unknown technological, economic, and political hurdles could push them further into the future. Colonizing Mars is one of the most daring endeavors humanity has ever contemplated. It will test our engineering, our resilience, and our willingness to cooperate on a global scale. Whether we succeed or not, the attempt will likely spark innovations that benefit life on Earth. If you enjoyed this deep dive and want more content about space exploration and the future of humanity, hit that like button, subscribe, and turn on notifications. Let us know in the comments what other topics you would like to see. Until next time, stay curious. The future is built by Science Bids. Ants.